Just after 3 in the morning by Coordinated Universal Time on the 2nd of November 2025, the night team at the European Southern Observatory settles into another quiet sequence over Paranal. The Very Large Telescope breathes into focus as adaptive optics flatten the atmosphere into a steadier sheet and calibration frames line up with the familiar calm of practiced work. The target is a known interstellar visitor that has been passing through the schedule for weeks, a routine monitor meant to catch modest changes in brightness and plume. Then the first science exposure arrives, and the routine surrenders to something that feels carefully impossible. Inside a living coma, straight edges materialize, meeting at corners so clean the eye names the figure before the analysis does. The image shows a hexagon where natural haze should dissolve into curves. Curiosity enters the room not as excitement but as concentration, because the data appear to be saying something that ordinary comets do not say. The team resists the seduction of pattern and turns first to the instruments. If a support structure in the optical path were printing a ghost, every star in the field would share its symmetry. They do not. If a reduction choice were carving order out of noise, an independent pipeline would refuse to produce the same outline. It does not. The raw photon counts themselves examined before any sharpening or subtraction trace faint but plainly linear boundaries through the fog, as if the signal has chosen to organize even at the most primitive step. A tighter filter repeats the outline. A shorter exposure repeats it again. The figure does not sharpen when pushed, and it does not fade when eased. It simply returns with the steadiness of a measured shape. Numbers begin to accumulate around the surprise. Vertex fits place internal angles near 120 degrees with deviations of only a few tenths of a degree from the ideal. Edge lengths cluster around about 4.2 kilometers, with individual measures ranging from roughly 4.18 to 4.23 kilometers depending on epoch and registration. The spread is small, on the order of 50 meters between the shortest and the longest side, a tolerance that in human construction would demand careful surveying and continuous maintenance. Here it appears while dust is escaping into sunlight and while jets write their shifting signatures across the coma. The curious data are not only in the outline, they are in how little that outline budges, while everything around it should be restless. Skepticism expands outward to the sky. Atmospheric distortion is not allowed to keep the blame. Frames processed with adaptive optics and frames left deliberate and soft both recover the same plan form when treated with conservative thresholds. Brightness profiles along the edges refuse the roughness that natural erosion usually brings to any long boundary. Within the resolution limit, the edge stays simple as if fractal texture has been held back. The center of light computed from concentric isophotes falls within a few hundred meters of the geometric center of the hexagon, a coincidence that would be easy to ignore once but is harder to ignore when it recurs across separate reductions. Photometry hints that polarization angles tend to lie along the drawn borders, a quiet alignment that promises a fuller map when the polarimeters are given their turn. By early morning in Hawaii, Gemini North has turned to the same visitor, a different hemisphere, a different telescope, a different atmosphere. The same 6 sides appear with the same calm regularity. Messages move across time zones in plain language. Raw frames attach calibration notes, included processing choices described with enough specificity to invite replication or refutation. Archival searches begin as colleagues ask whether any earlier images once dismissed as noisy or indistinct are ready to confess a pattern now that the eye knows what it is looking for. A reprocessed frame from late October quietly sharpens a corner that once looked like chance. The Hubble Space Telescope explores windows for a rapid observation, and planners begin their careful dance around other obligations. The analysis deepens without accusing. Angles measured across multiple epochs persist within a tolerance that feels more like engineering than geology. Edge lengths, when plotted against time, hold their values rather than wander with sublimation. The probability work starts cautiously at first, then with firmer priors, natural fracture can make straight lines, magnetic fields can impose order, resonance can set patterns in moving media. Yet each pathway carries weaknesses that the numbers exploit. A 6-sided figure with sides of almost equal length and angles within a fraction of a degree of 120, maintaining alignments while the nucleus rotates, would be an extreme draw from any natural deck. The team does not claim what it cannot prove. They do, however, name the data as curious in the most precise sense. The measurements do not relax into familiarity when pushed. They become more insistent. Quantities keep finding one another. The center of symmetry and the photometric center remain nearly co-located. The borders stay smooth at the instrument floor, with reflectance over the faces more uniform than expectation. The coma's light falls away in a way that respects the geometry rather than erases it. None of these signals alone would be persuasive. Together they behave like witnesses who do not share notes but somehow tell the same story. The picture is not a verdict, it is a set of constraints that narrows the room in which ordinary explanations can stand. The telescope turns, the desert brightens, and the outline remains where it was drawn, present in the photons and patient in the numbers. By the time the domes close against the rising day, the plan is simple and sober. Repeat the measurements across a rotation, map polarization with better precision, invite yet more independent pipelines to try to make the figure go away. Ask for other wavelengths so that the outline, if real in the material and not only in the light, will announce itself the same way in ultraviolet and infrared and radio. The night has delivered data that should not exist and yet do exist, and the response is to let the data keep speaking. Curiosity is kept at the same steady temperature as skepticism. The hexagon does not hurry anyone. It simply holds its place inside the coma, like a ruler laid across a breeze, and the work, now that it has seen, it prepares to follow the line wherever it leads. The circle widens with the steadiness of habit. Before dawn has lifted from the Pacific, a copy of the raw frames travels to collaborators who prefer to see the sky before any algorithm lays a hand on it. Headers stay intact, calibrations are described in plain language, and nothing is hidden behind a favored workflow. The practice is older than the anomaly. When something improbable appears, independence becomes the instrument that matters most. A second team runs reductions with their own code built on different mathematical foundations, the kind of parallel line that either intersects at agreement or shows that a mirage was walking in the first place. The same 6 edges step out of the haze, and the same corners hold their measure. Gemini North turns its mirrors toward the visitor under air that has crossed the ocean rather than the desert. Different optics, different coatings, different support structures, and a guide star that sits at another angle with respect to the instrument all join the test without ceremony. The outline returns. The angles gather again near 120 degrees. The side lengths cluster near 4 1/5 kilometers, with differences that old hands call small, not because they are casual, but because they have met true variance in less obedient targets. The sky does not repeat itself unless there is something to repeat. Here it repeats with the quiet of a rule. Word moves not as excitement, but as inventory. Exposure times, seeing estimates, median sky values, and detector temperatures are recorded alongside the images so that nothing is left to guesswork. A team in Europe chooses a deconvolution that is gentle with edges. Another in North America chooses one that is conservative with noise. A third in Asia leaves edges entirely to the instrument response and concentrates on registration so exact that subpixel shifts are kept in a ledger. Each path produces the same figure. Straightness proves robust against method, and angles prove stingy with deviation. The object resists the usual ways in which enthusiasm can shape an outcome. By late morning, coordinated universal time archives are no longer quiet shelves. Observers pull frames from earlier in the season, moments that once looked like small blurs in a busy program, and hold them to a new standard of attention. With cleaner subtraction, with the center now held to the geometric average rather than to the brightest pixel, with the point spread function modeled by a different star, in the same frame faint lines that once looked like chance now align in a shallow V that becomes a corner when stacked with care. The story does not change the past, it simply makes some of the past legible. A message goes to the team that manages the Hubble Space Telescope. Windows are tight and obligations are many, but the case for a brief look is simple: an independent platform above the atmosphere, a detector with a personality that has been known for decades, and the ability to collect light that has not touched air since it left the object. Schedulers search for an opening. In the meantime, older Hubble images of the field are reprocessed with the new question in mind. Even when resolution is not quite enough to draw the full figure, the brightness along the expected border is fractionally higher than across the faces. The difference is small, nearly lost in noise, and yet it is consistent with the line traced from the ground. Wavelength becomes a second axis of independence. Near-infrared exposures are taken on a mountain a hemisphere away. A narrowband filter tuned to carbon dioxide shows a slightly brighter run along the same 6 tracks. Broadband optical light lines up as if it were a faithful copy of an underlying design. Early radio checks are coarse, but their emission from certain molecules prefers the perimeter. The precision is not yet the precision that later instruments will bring, but it is enough to say that the geometry does not live only in one color. It seems to live in the material, and light of many kinds learns its edges. The calculation of probability is not drama, but housekeeping. Straight lines can happen in nature. Equal lengths can happen by coincidence. Angles can land close to a round number when the measure is noisy. But when 6 independent edges match within a small fraction, and when the angles stay within a few tenths of a degree across images made with different glass and different air, the space for coincidence narrows. Teams lay out their priors in public state, their thresholds before they stare too long, and then do not move the thresholds after the fact. This discipline keeps wonder from sharpening into claim before it should. Conversations remain careful. There is no rush to explain with crystals, with magnetism, with resonance, or with scattering, though each possibility is named in turn and left waiting on the table. The present task is simpler: determine whether the outline is real in the photons and not a whisper pass between methods. To that end, independence goes deeper. One group works only from raw counts with minimal modeling. Another insists on forward simulations, creating artificial hexagons of varying sharpness and letting the pipeline either recover them or fail. The real data behave as though the figure is neither an artifact of cleaning nor a phantom of overfitting. It announces itself even when the analysis is skeptical on purpose. By midday, more than a dozen facilities have either confirmed the plan form or found hints consistent with it at the limit of their reach. The phrase that repeats in internal notes is modest same geometry within uncertainty. Those words are not excitement, they are a load-bearing beam. Precision drifts toward a tighter bracket as exposure stacks grow. Corners that were soft become cleaner. A cumulative plot of measured angles narrows like a river forced through a canyon. A plot of side lengths against epoch stays almost level, a quiet horizontal line where one would expect a slow climb or fall. The object rotates, but the figure does not flutter. Some of the most persuasive testimony comes from what fails to correlate. The edges do not align with diffraction spikes. The corners do not shift when guide star choices change. The apparent straightness does not strengthen when an algorithm that favors edges is applied, which is to say the figure is not something invented by an analytic appetite. Even the background field is pressed into service. When stars pass close to an expected border, the edge does not bend to accommodate their noise. It keeps to its rule. The geometry behaves as though it belongs to the object and not to the tools that look at it. As the sun rolls west, the tone remains level. Confirmation is not celebration, it is permission to proceed. The community agrees on a short list of next moves. Hold coverage across a full rotation so that any drift can show itself. Add polarimetry under stricter control. Seek an angle change large enough to test depth, perhaps from a different world entirely. Ask for time on instruments that taste heat rather than light. Each step is a way to ask the same question again with a slightly different accent. Angles too precise to ignore have become a shared responsibility. The figure rests within a cloud that should not draw a ruler, and yet it does, and the world, now properly cautious, prepares to keep looking until the shape either teaches or dissolves. Work turns from recognition to measurement, from the surprise of a shape to the patience of numbers. Astrometry becomes the workbench where every choice is weighed. The field solution is rebuilt against trusted catalogs so that each pixel knows its exact place on the sky, and distortion maps are refreshed to keep edges honest at the corners of the detector. Point spread functions are tuned star by star because form hides in the wings as much as in the peak, and a small bias there could tilt a line that ought to stay straight. The promise is not drama, only accuracy. Edges are traced in ways that refuse to beg the answer. One method follows brightness gradients until a ridge holds steady through noise. Another models the coma with restraint, subtracts it, and fits straight segments only to what remains. A third scatters candidate lines at random, resamples the image many times, and keeps only the survivors that reappear when the data are shuffled. Corners are carried as neighborhoods rather than points, so each vertex is a small cloud of allowed positions whose size records uncertainty instead of hiding it. Lengths arrive first because they ask the simplest question. Across multiple epochs from the middle of October to the second day of November, 6 sides stay near 4 1/5 kilometers. The shortest and the longest differ by roughly 50 meters. On paper, that fraction is near 1.2%. In practice, it is a calm defiance of what activity should do. Volatiles stream away, grains lift into sunlight, and yet the ruler keeps its measure. In construction on Earth, such uniformity would demand lasers and constant maintenance. Here it appears while the object breathes. Angles follow. Internal measures hover close to 120 degrees, with deviations inside about 0.3 of a degree, no matter which reduction speaks. When tenths and degrees begin to blur in the mind, a homely image puts scale back on the table. A pencil held at arm's length against a wall, the length of a city block is near the largest difference between the ideal and the measured corner. The line between almost and exact is narrow, and the figure chooses the narrow side again and again. Rotation is given its turn to spoil the picture and does not. Over a period near 18 hours, the illumination changes, the viewing phase shifts, and jets that should smear structure whisper along the same border instead. The edge does not flutter with spin, it rides it. That persistence invites a deeper check in the center where false alignments often hide. The geometric center from the 6 vertices is compared with the photometric center from the coma's light, and the two sit within a few hundred meters through night after night. Light is free to wander, it chooses not to. Texture at the limit of resolution adds another quiet piece. Faces look plain rather than grainy, and borders refuse to meander. Natural edges on airless bodies and crater rims usually reveal new irregularity as scrutiny grows. Here the measure approaches its floor and still finds simplicity. Reflectance across a face varies, but less than expected for a patchwork of ice rock and processed crust. There is no claim that the surface is polished, only the observation that roughness acts as if it has been damped across scales where it normally multiplies. Statistics keep wonder in its lane. Bootstrap resampling asks whether a few silent outliers carry the whole claim. They do not. Synthetic hexagons with slight bows are injected into raw frames and pushed through the same pipelines to see how curvature might masquerade as straightness. When curvature is present, it is recovered. When it is absent, it is not invented. Simulated Comet seeded with fans and shells are blurred by instrument models, then measured blind. Spurious edges come out noisy and short. The real edges come out long and consistent. Independence stays the most valuable property. Code that prefers smooth derivatives agrees with code that prefers robust fits against large residuals. A team that allows gentle manual seeds lands the same angles as a team that forbids any hand on the tiller. Mosaics that stack many short exposures agree with single long frames that avoid alignment entirely. What ought to change the answer does not. What ought to make no difference does not either. Convergence grows not because anyone wants it, but because methods that disagree for sport still arrive together. Only then is probability allowed its say. Straight lines happen in nature, 6 of them of nearly equal length meeting at the exact classroom angles and keeping those measures while the object turns and exhales are rare. With priors stated in public and uncertainties kept conservative, the odds that random fracture flickering jets and viewing geometry alone would assemble this figure fall to something like 1 in 10 billion. The number is not a headline. It is a weight placed on a scale so that everyone can see it. There is a plot on a shared screen that looks like rest. Edge lengths against time form nearly level tracks. Angle deviations against time form a shallow braid that refuses to drift. The offset between geometric and photometric centers bounces and returns to the same small value. Nothing calls for a rescue. In a field where noise often rules and outliers tug the eye, this refusal to wander reads like a high-pressure day after weeks of wind. Calm is data too, and here calm accumulates. By the end of the 3rd careful night, the figure is measured rather than guessed. 6 sides near 4 and a 1/5 kilometers angles near 120 degree centers, nearly co-located faces that choose smoothness over grain, and a time series that does not flinch. None of these lines demands a single conclusion. Together, they redraw the map of plausibility. Natural stories must stretch to include precision at mountain scale. Speculative stories must earn passage past the same numbers. The shape holds its ground, and the numbers now orderly ask what deeper rule keeps them there. Attention turns from the grand outline to the smallest shapes that light can carry. Texture becomes the question. The analysts set out transects that cut across each border at right angles and then walk those lines 1 pixel at a time, watching how brightness rises and falls. On most natural surfaces, the transition from dark to bright at an edge is ragged when seen closely, a little sawtooth of shadowing pits and protrusions. Here the transition is simple. Brightness climbs, holds, and falls again in a way that can be modeled with a clean slope and a shelf, as though the surface chose restraint instead of fuss. The simplicity survives when exposure time changes, when the image is rotated, and when the coma is fitted and removed with different models. The borders act as if they know they are borders. Faces are given the same scrutiny. Reflectance across each hexagonal plane drifts only a little less than the handful of percent that would be expected from a natural quilt of ice dust crust and shadow. To keep themselves honest, the teams swap the masks that define where an edge ends and a face begins. The uniformity remains. When noisier frames are stacked into calmer pictures, faint modeling retreats and does not reappear as the data improve. A desert of small variations does exist, but it is the kind that belongs to light and distance rather than to a boulder field or a scarred plane. Words that belong to instruments are translated into plain speech and then used with care. The point spread function, which is the way a perfect point of light smears inside a real telescope, is mapped star by star so that no hidden curl of the optics can pretend to be a smooth wall. The modulation transfer function, which tells how contrast at different scales survives the trip through glass, and air is measured with calibration fields so that the images can be corrected in ways that are gentle and reversible. After that housekeeping, the power carried by small ripples and fine bumps on the faces is measured by looking in frequency space rather than in the picture itself. Natural terrains usually give a falling line that shouts how roughness multiplies as scales shrink. The faces here whisper instead. High frequency power is smaller than expected. Fine structure is faint where it ought to be busy. Deconvolution, the mathematical act of sharpening, is distrusted on purpose. One group sharpens not at all and works only with raw frames registered to a common grid. Another applies a mild deconvolution that has been validated on objects with known texture. A third blurs the images in a controlled way and then asks whether the figure vanishes under that gentle handicap. In all three cases, the conclusion is the same. The silence in the grain does not come from the knife of an algorithm. It seems to come from the object. To make sure this is not wishful thinking, synthetic fields are prepared. Researchers place artificial, slightly bowed edges into raw noise and see how their pipelines treat them. They seed fake faces with boulders of many sizes and watch whether any combination of processing can flatten that invented chaos into a tidy sheet. The tests fail in a useful way. When roughness is planted, roughness remains. When a border is bent, the bend is recovered. The real pictures are not hiding a busy truth. Light itself is asked for an opinion. As the phase angle changes with rotation and orbit, natural surfaces usually grow redder or bluer in a dependable way and show limb darkening, the dimming that comes when one looks more along a surface than at it. The faces of this figure show those behaviors only weakly. Color does change with geometry, but less than expected. Limb darkening exists, yet it is remarkably even across a face, as if the microtopography that usually modulates that fall-off has been smoothed. Polarization measurements, still crude but improving, find that the electric field of scattered light prefers to line up with the drawn borders, a quiet sign that particles and facets share the same orientation across large distances. Comparisons to familiar worlds help set scale. Images of the comet visited by the small lander that once rode with a European spacecraft show cliffs that crumble and plains that crack into polygonal plates. The rubble is everywhere and new roughness appears whenever resolution improves. The small asteroid explored by a sample return mission is even more democratic. Boulders stud every frame until the eye learns to swim through them. The contact world at the edge of the planetary belt is gentle in outline and yet still carries ridges, pits, and subtle shelves wherever sunlight reveals them. In that company, this hexagon is an outlier. At a working resolution near 10 meters, which is to say features smaller than a city bus, the faces are quiet and the borders are crisp. If small hills or pits exist, they hide below the floor of what the present optics can see. Could the coma be smoothing everything, smearing a real roughness into false steel? The question is pressed from several angles. When the coma is modeled with either simple radial profiles or more complex anisotropic flows, and then remove the edges, keep their special calm. Narrow filters that isolate the light of one molecule trace the same borders that broadband light traces. Infrared images that listen to heat rather than to color place the same planes beneath the same sky of dust. Even a first-course look in radio emission from subtle lines that belong to simple molecules hints at an outline that repeats the geometry. If smearing is the artist, it is a very disciplined one. Natural smoothing mechanisms are invited to try. Fine dust can mantle and fill small relief, a process seen on many small bodies. Recondensed frost can sheath a landscape after a burst of activity. Electrostatic levitation can loft grains and then lay them down again in a more even coat. Each of these is tested against the numbers. Mantles fill, but they also streak and gather and leave tracks, and the faces do not show those tracks within the limits of sight. Frost brightens and fades with temperature and light, but brightness across the faces does not breathe in that way. Electrostatic sorting tends to build patches and dunes. Instead, the faces hold a sheet-like sameness. Nothing is ruled out, but every simple story must work harder. Edges in natural settings also tend to scallop and retreat because sublimation eats at corners and cracks faster than at planes. Here, the borders stay straight within the floor of the data. Cross-sections taken in many places and at many roll angles show no preferred nibbling. Jets passing near do not carve bays. If the border is an interface between materials of different strength, it behaves like a seam that resists being pulled apart. If it is only a light trick, it is a trick that keeps its punchline even after every attempt to change the room. By the end of this phase, the picture of texture is strangely restful. Borders with clean profiles, faces with modest variance, a spectrum of roughness that falls quiet where it ought to chatter, and a set of tests that try to invent noise and fail to do so. No single measurement is an answer. Together they form a negative space around an answer, a structure that prefers evenness, that damps small chaos, that allows geometry to stay legible while the object turns and exhales. The silence in the grain is not yet a proof of anything beyond itself. It is a property measured and repeatable that any explanation must carry forward without breaking. Time becomes the instrument that asks its own questions. A shape glimpsed in a single night can still be an accident of viewing, but a shape that returns after the sky has turned and the object has spun earns a different kind of trust. Schedules are reshaped around that idea. Sequences are booked not for a moment, but for a full turn of the body, then for another, and then for a chain of cycles long enough that the hours themselves become data. The plan is modest in tone and ambitious in patience, hold the scene steady, while rotation, illumination, and perspective do their best to loosen the outline. If the geometry is real, it will keep finding its own way back into the frame. Photometry provides a slow, steady pulse to mark the time. Brightness rises and falls with a period close to 18 hours, a rhythm that belongs to a principal spin rather than to a restless tumble. The modulation is polite, a gentle swell and ebb that suggests a mostly uniform surface, presenting slightly different cross-sections to the sun and to the earth. Plotted without embellishment, the light curve repeats night after night with the same crest and trough. When measurements taken at high phase angle are separated from those at low phase angle, the rhythm remains coherent, a simple sign that the geometry of illumination changes while the body keeps its cadence. To keep rotation from misleading the eye, analysts build the pictures twice. In one set, every exposure is assigned a phase within the 18-hour cycle and stacked only with frames that share that phase on different dates. In that co-rotating alignment, the coma breathes. Jets shift, faint knots drift outward and fade, and yet the 6 edges stay seated in the same places as if drawn on the plate. In the other set, the sky is kept fixed, and rotation is ignored on purpose, a test meant to smear any pattern that truly rides the nucleus. The border softens a little as any edge should under that treatment, but it does not dissolve. The two approaches, one that moves with the object and one that holds still against it, are reconciled by measures that agree within their stated uncertainties. Centers are asked to testify again. The geometric center calculated from the 6 vertices and the photometric center derived from the coma's brightness are followed through many rotations. They wander by a little and then return like a compass needle that has been tapped and finds its north again. The offset stays within a few hundred meters. More telling, the variance does not grow with time. That calm would pass without comment in a boulder that is quiet and cold. It draws attention in a body that exhales gas and dust in measurable quantities. The coincidence implies that whatever organizes the light also sits close to whatever organizes the shape. Edges receive time-resolved transects. Profiles taken across a border at the same rotational phase on different nights overlay within the width of a single pixel. Profiles taken half a cycle apart match as well aside from the small lawful changes that come when sunlight reaches across a plane at a different angle. Corners behave with the same restraint. In one check, small circles are fitted around each vertex, and the fitted centers are tracked as the object turns. They do not walk across the detector. The figure rotates with the body, not with a wandering glare. Perspective is allowed to make its honest argument. As Earth moves along its orbit, parallax bends the line of sight through the coma by a small amount each night. If the hexagon were a projection effect from a very specific arrangement of scattering grains, that nightly change should weaken or distort the alignment. Observers therefore value the nights when parallax is largest, giving the figure every chance to surrender its order. It does not. The border keeps its measure as background stars slide by in their own indifferent straight lines. When equipment permits, cadence is tightened to listen for flicker. 10-minute sequences are chained together to look for microbursts or small oscillations in jets that might tug at an edge. Bright knots pass like weather across a hillside, but the hillside does not move. A different cadence stretches across days to ask whether fresh regions waking into sunlight can build a slow drift in the outline. Once again, the answer is level. From one week to the next, the numbers remain within the same narrow brackets, and the plots look like rest. Complex rotation is addressed rather than assumed away. A clean principal axis spin would make the stability easier to accept. A slow precession or a soft nutation would build faint lawful wobbles into the geometry. Simulations combine reasonable moments of inertia with outgassing torques and ask those configurations to spoil the picture. None of them finds a path that keeps long, straight borders crisp in a living coma while letting the real corners slide on the nucleus underneath. The simplest reading, that the edges are tied to the body and ride with it, remains the reading that refuses to break under test. Wavelengths return to the time question together. Bands that trace water, carbon dioxide, and neutral dust are each stacked by rotational phase. Each time the border returns. The ratio of brightness does change with chemistry. Water leans toward the vertices, carbon dioxide follows the faces, and dust keeps a more even hand across the plane. Yet the map itself does not blink in and out as a rotating fan might. The chemical differences ride the same geometry rather than writing a new one. Skepticism is kept in working order by an inventory of small failures. Analysts search for correlations with field rotation, with air mass, and with the subtle walk of a guide star across a sensor. None appears. They build composites from the blurriest nights to see whether the border dissolves when the atmosphere makes its strongest case. It softens as any edge must, and then reappears in the next clear run with the same angles and the same lengths. They check whether the periodic swell of brightness smears the outline when long stretches are stacked. It does not. The measurements remain parsimonious, as if the figure prefers to conserve its own information. A calendar grows its own quiet geometry on a shared screen. Circles mark nights when observatories watch together. Crosses mark nights when weather erased the field. Thin arrows note how the viewing angle changed. The hexagon does not seem to notice the calendar's history. It keeps its proportions through the small daily parallax of Earth, through the nightly turn of the sky, through the internal rhythm of the object, and through the shifting breath of the coma. Weeks pass, then more weeks. What first looked like an outline in a November image behaves like a companion that simply keeps pace. By the end of this chapter, measured by hours, persistence itself has become a result. The figure is not a passing alignment, nor a friendly accident of glare and grain. It is a boundary that stays attached while the body rotates, while illumination changes, and while the line of sight tilts slightly from one night to the next. The cadence has given the geometry many opportunities to contradict itself. Instead, it has chosen to become more itself, narrowing the space in which fleeting explanation can stand. Any account of what draws those edges, whether a process of nature pushed to an unfamiliar scale or a principle of organization not yet named, must accept one clear condition set by time: the shape holds fast while everything around it moves. Color becomes a second path to certainty. The same outline that holds invisible light is asked to present itself in other tongues that light can speak. Ultraviolet frames from the Hubble Space Telescope are the first to answer. Above the air and its shifting glass, the detector reads the high-energy scatter from tiny grains and molecular bands that glow when sunlight breaks them apart. The coma looks more ragged in this register strands and lace rather than smooth breath, yet the border still comes through as a quiet insistence. Brightness falls a little faster across the faces and clings a little longer along the edges, as if the geometry reaches into the way small particles learn to shine. Ground instruments give the near-infrared their turn. Filters tuned to water lines and to carbon dioxide pull different stories out of the same light. The map of water tends to peak at the corners as though the vertices host pockets that exhale more freely or that funnel gas into tighter columns. Carbon dioxide prefers to trace the 6 long runs rising like a seam that has learned to breathe. Neutral dust seen in broad bands where color is less picky spreads itself more evenly across the plains, yet still shows a shallow ridge where each border lies. None of these images is a perfect copy of another, and yet each of them respects the same drawn plan, as though chemistry and geometry have agreed to share a script. Thermal emission folds a different sense into the effort in mid-infrared bands. Heat itself becomes the messenger. Surfaces warmer than their neighbors speak a little louder, and materials that conduct or store heat differently answer with their own timbre. At first the picture is softer than in reflected light, a quilt of warm and cool that quiets the farther one looks from the nucleus. Even so, the change from face to border behaves like a step rather than a slope. The line is not razor sharp, but it is too regular to be weather. When phase changes, when the sun slides to a new angle and shadows would normally stride across a rough land, the separation between plane and edge remains nearly the same. Where one would expect thermal texture to betray hidden roughness, the figure remains tidier than habit says it should. Farther out on the spectrum, the Atacama large millimeter and submillimeter array tunes to simple molecules that ring like small bells when they spin or vibrate. Carbon monoxide, hydrogen cyanide, and the humble hydroxyl radical each outline the gas that escapes into space. The array's baselines combine into a resolution that, while coarser than the sharpest optical frames, still tests shape against independence of method. The emission is not an even fog. It strengthens along the same 6 paths and softens across the same 6 planes. Velocity information adds a small but telling layer. Where a rotating fan might draw a spiral or a set of alternating plumes, the Doppler shifts trace flows that respect straight boundaries as if channels are present or as if activity is favored where a long line meets open space. The very large array listens at longer radio wavelengths to lines that are fainter but stubborn and to continua that are softer still. Here the coma becomes a whisper across a bright sky, and the work is careful subtraction before any meaning can be heard. In stacks that span hours and then days, the residual emission maps onto the same figure. The match is not perfect. Radio images are honest about their blur. Yet the best fit polygons that climb out of the data keep the same side lengths and meet at corners that fall within the same narrow bracket of angles. The recurrence adds weight because radio care little for the tricks of optical scatter. It reads density and motion in its own way and still finds the same drawing. Polarization runs through all of this like thread. In reflected light, the electric field that the detector measures is not random. Where small, irregular grains throw light in every direction, polarization angles arrange themselves like a wind that has no map. Along the borders, however, those angles tend to lie parallel to the edges, as if facets or elongated grains have aligned, or as if the boundary itself introduces a preferred direction into how light is sent toward the instrument. In near-infrared, the same alignment appears with smaller strength. In ultraviolet, it becomes a little stronger again, possibly because the smallest grains are taking the lead. Even in the thermal bands where polarization is often shy, a hint of order does not fully vanish. Across many colors, the geometry persuades even the vector nature of light to pay attention. All of these measurements are forced to pass the same gauntlet of doubt. Illusions born of scattering can draw rings and arcs at certain sizes and certain colors. The teams therefore build forward models in which particles of different radii and shapes fill a coma without any hard borders, and then shine as physics says they will. Some models can create brightening that looks like a faint wall at one wavelength. The same models fail at another. The match collapses, or the phase dependence goes wrong, or polarization begins to wander away from the clean alignment that the sky has shown. When the inputs are forced to keep the figure across all bands at once, the models drift toward unphysical mixtures or require choreography so delicate that it is no longer an honest baseline for nature. Calibration remains the quiet hero. Stars with known colors and stable polarization are observed before and after the comet so that the instruments remember how to speak plainly. Detectors are checked for ghosts and for small leaks between filters that could pretend to be signal. In radio side lobes that might paint a false straightness are mapped and removed. In the infrared, the tails of the point spread function are modeled with care so that a gentle glow does not masquerade as a face. After each correction, the images are built again and the hexagon endures. The result is not a sharpening into perfection but a refusal to go away. A picture begins to settle not as a verdict but as a set of constraints that any story must carry. The geometry does not belong to a single color. It belongs to the way matter is arranged. Borders gather gas and guide it. Faces hold a quieter mix of dust and ice. Heat respects the same lines that reflected light respects. Radio emission obeys the same map that optical polarization obeys. If a trick is present, it is a trick that stays coherent across the spectrum and through time, which is a poor habit for a trick and a good habit for a structure. The more voices that are invited to speak, the more they sound like a chorus that has learned the same song. By the close of this spectral tour, the case is not that nature cannot draw such a figure, only that any explanation that leans on a single effect has run out of space to stand. The same outline appears when light bounces, when heat leaks, and when molecules sing. Polarization rotates to follow the lines. Wavelengths that favor different grain sizes still agree on the same border. The message is plain and calm. Whatever draws those edges is not a quirk of a filter or a fashion of a particle. It is a plan that the material itself keeps returning to even as the color of the question changes. Nature is given first refusal because it knows how to draw patterns and often prefers economy. The working mindset is simple. Begin with familiar physics, push it gently, then push it hard and keep only what survives measurement. The hexagon sits at the center of that exercise like a quiet examiner. It does not argue. It waits while one hypothesis after another is invited to explain how edges can stay straight, how angles can stay close to 120 degrees, and how a living coma can keep a ruler's calm through light, heat, and time. Crystals are allowed to speak first because 6 is their native grammar. Water ice builds hexagons from the bond angles of its molecules. Snowflakes are proof laid on windows and sleeves every winter. The problem is scale and company. Laboratory growth yields order across millimeters and sometimes across centimeters. The faces now measured are each a few kilometers long and sit inside a mixture of dust organics and more volatile ices. Radiation in interstellar space breaks lattices. Thermal cycling near a star opens fractures. Impurities lock themselves into the framework and disturb the tidy repeating distances that long crystals require. Even if a massive single crystal ever forms sublimation should roughen and round it with time, not polish and protect it. The hexagon at hand behaves as though it can ignore defects in weather, and that is not how crystals live at these temperatures and scales. Magnetic ordering is next. Saturn holds a 6-sided wave around its north pole because rotating fluids can set standing patterns when the winds and the planetary spin strike a careful balance. Charged grains in a coma do respond to magnetic fields. Lines of force can point a preferred way to travel. The measurements, however, are ungenerous. The interplanetary magnetic field near the object changes with the solar wind, and yet the geometry does not twitch. No strong local field asserts itself in a way that would carve a hexagon through charged gas. Limits set by remote sensing fall well below the strength that would be needed to sculpt kilometers of order against the pressure of outflow and starlight. Magnetism may nudge, but it does not seem to rule here. Resonance and vibration bring an alluring vision, plates of sand on a speaker powder running to nodes as a tone builds a standing wave, hexagons appearing where silence crosses sound. A nucleus has natural modes and outgassing might feed them, but a resonator needs steady power and the available engines are weak. Tides from the sun are gentle at this distance. Radioactive heat in a small cold body is a candle, not a furnace. If resonant modes were somehow active, the geometry should breathe in time, edges brightening and dimming as nodes and antinodes march. Instead, across rotations and weeks, the border holds without the expected choreography. Simulations that combine plausible stiffness with realistic damping leave little room for a tone that can carry a mountain-scale figure without fading. Projection and perspective are given their turn because eyes and instruments can be fooled when angles are kind. Rough hills can align like a skyline that reads as a straight line from one street and as a jumble from another. The past nights have not been kind to that hope. The object turns on a rhythm that is measured in hours, the phase angle changes, and the brief nightly parallax of Earth shifts the view. Through all of that movement, the figure does not blink in and out, and edges do not bow into arcs that would betray a trick of viewpoint. The geometry rides with the body rather than with a line of sight. Scattering by dust can draw rings arcs and even bright rims when grain sizes and colors line up just right. Forward scatter can make a halo near the sun. Backward scatter can lift a limb. The multi-wavelength campaign has asked exactly that question in many colors. Ultraviolet finds the figure. Visible light finds it again. Infrared that prefers heat keeps the same lines. Radio that listens to rotation in molecules lays a similar map. Polarization, a fingerprint of how light is redirected, aligns itself along the borders instead of wandering in patterns that scattering alone would favor. Models that force grain populations to keep the hexagon across all those bands end up strained and brittle, and they do not hold when the data are shuffled. Fracture is an honest worker in stone and ice. Basalt on Earth cools into columns that sometimes arrange themselves into near hexagonal pavements. That analogy offers an anchor and then slides away. The columns on Earth measure in meters, not kilometers, and they curve and step at many scales. Their edges scallop. Their faces carry grooves and chatter marks where cooling argued with contraction. The borders under study are straight within the limits of 10-meter pixels, and the faces are quieter than such pavements even dream of being. Scaling laws matter. They do not bend this far without breaking. Mantling and frost can hide roughness. Dust can settle and fill small relief. Ice can recondense sheath irregular ground and mask fine texture. Those processes have been seen on other small bodies and are written into this assessment as living options. Their signatures, however, are missing or muted. Mantles migrate under weak winds of gas and electric fields. They leave streaks and dunes. Frost brightens with morning and fades with afternoon, leaving color that breathes with temperature. The faces here remain even through changes that should wrinkle them if mantling or frost were the main authors. Small signs of those acts may exist below the present floor of sight, yet they do not carry the geometry on their shoulders. Tidal stress and ancient collisions are offered as sculptors that can draw planes and edges at once. A near pass by a massive body can fracture and cleave. A glancing blow can leave facets that remember direction. The patterns left by such violence are usually radial, concentric, or chaotic, a record of shock rather than a ruler's work. They blur with time and sublimation, unthreads their straightness, eating corners first and faces later. Here corners stay where they should, and faces age slower than the surrounding haze. If a catastrophe once wrote the plan, something else has been keeping it legible against weather that should erase it. None of these pathways is mocked or discarded lightly. Each is tested with the best numbers at hand, and each fails in a different way. Crystals promise the right symmetry and the wrong durability. Magnetism offers control but lacks force and constancy. Resonance offers pattern but not power. Projection offers convenience but not persistence. Scattering offers brightness but not coherence across color and polarization. Fracture offers planes but not their patient maintenance. Mantling offers smoothing but not the clean straightness that the edges prefer. What remains is not a verdict against nature, only a narrowing of the space in which nature can stand and still keep faith with the measurements. The temper of the work stays level. Nature has surprised astronomers many times, and it may do so again here, but any natural story must now adopt strict conditions, straight borders that stay straight within 10-meter sight angles that stay near 120 degrees through many turns, faces that refuse to chatter at fine scales, chemistry that honors the same plan across colors, and a timeline that ignores small disturbances. With those constraints laid down, attention turns to the placement of the figure itself. If the geometry belongs to the coma, it must be fed and held by flows. If it belongs to the core, it must be anchored in material. The next step is to separate light from body with sharper depth and to ask where the outline truly lives. The question narrows to location. The hexagon is visible in light and heat and radio, but does the geometry live in the gas that surrounds the body? or in the material that the gas escapes from. The distinction matters. A border made of flow can be moved by pressure by sunlight and by subtle coupling to the solar wind. A border cut into the core must obey strength, fracture, and mass. The observing plans shift to separate those two worlds, asking the coma to step aside long enough for the nucleus to answer on its own. Depth is the first lever. Tomographic reconstructions are built from sequences taken at slightly different viewing angles and slightly different phases, each image contributing a sliver of constraint to the three-dimensional map. The method is an onion peeled by mathematics. Brightness is modeled as emission along many lines of sight through a cloud that expands and that rotates, and then the model is asked to find the distribution that would produce all the frames at once. Straight borders are stubborn when projected through depth. Even a modest tilt or stagger will make them bow. In the early inversions, the hexagon keeps its edges. Where the gas density is highest, the solution chooses planes rather than curves, and the choice repeats as more nights join the stack. Opacity adds a second lever. Background stars pass behind the coma by chance, their small, steady lights providing needles that probe the thickness of dust and gas. When a star tracks across a face, its light dims by a certain fraction, and the time it takes to recover tells how quickly the coma thins along that path. When a star grazes a border, the dip grows a little deeper and straighter in time, as if the path has crossed a wall rather than a slope. Not every passage is perfectly placed, and scatter still speaks loudly, but over many grazes the pattern is clear enough to draw along the edges. The column is higher, and its gradient sharper, and the change in time follows the 18-hour rhythm, as though the wall rides the body. Velocity becomes a third lever. Millimeter spectra do not only map where molecules glow, they measure how quickly those molecules travel toward or away from the instrument. If the hexagon were written only in the gas, the velocity field would show continuous drift across each face and sudden changes at each border, a kind of traffic map laid over a city grid. When the data are sliced by rotational phase, the discontinuities do appear near the borders, but their positions in the sky rotate with the same steady cadence as the outlines seen in reflected light. The drift pattern is tied to a frame that turns with the object, not to a fixed direction in space. The geometry does not seem to be a freestanding pattern imposed from outside. It seems to be fastened to the core. The center test is repeated under this new light. The geometric center is already known, and the photometric center has been tracked through many nights. Now a mass proxy is added by modeling the coma's pressure field. In flows that simply erupt from a rough surface, pressure piles up where jets collide and dips where they part. In flows organized by an underlying frame, pressure traces that frame, and the center of pressure sits near the same place as the geometric center. Within the reach of the models, the result lands on the latter. The alignment is not perfect, and it is not required to be, but the small offset behaves the way a body-fixed arrangement would behave. A different family of tests leans on timing. If the hexagon belongs to gas alone, its outline should lag behind the nucleus as fresh material climbs outward. A delay of a few minutes to an hour would shift the border ever so slightly ahead of or behind the surface pattern with phase. The campaigns that stack by rotational phase are refit to allow such a sliding. The preferred solution refuses the lag within the available resolution. The border's phase remains that of the nucleus to within a small fraction of the spin. Dust lifted from a fixed seam would behave like this. A free pattern blown into shape would not. Brightness anisotropy across the faces provides a softer clue. A face illuminated more obliquely ought to show a thermal gradient that drifts with phase if its appearance is written in gas. Instead, the thermal step at the border remains nearly the same thickness and contrast as the sun walks to a new angle across the day. Where a gas wall alone might swell and shrink, a wall with substance beneath it would stay nearer its own measure. The data choose the latter behavior more often than they choose the former. None of these arguments alone forbids a coma origin, and the language used in the internal notes stays plain. The hexagon could be a pressure architecture held in place by flows that replenish and cool. It could be an interaction between grain charging and the small electric fields that often arise where gas and dust part company. It could be a network of jets that have by some accident of fracture learned to fire in a pattern that draws straight lines when averaged over time. Yet each of those stories must now explain why the figure is phase-locked to the turning body, why the depth reconstruction prefers planes and corners, why background star dips are steeper at the edges, and why the thermal step acts like a boundary with memory. A path forward comes from combining models that usually live apart. Surface physics is married to flow and flow is married to light. The boundary conditions that flow requires are drawn from the measured edges and their timing. Jets are allowed to fire from vertices more strongly than from faces, and the gas expands into space with the usual scalings for speed and density. The coma that results reproduces much of the brightness distribution only when the sources are laid out along the measured border and when those sources rotate with the object without lag. That agreement is not proof of a solid wall, but it is a hint that the coma is being written by a template rather than writing the template itself. The cautious conclusion is a layered one. The hexagon is visible in the gas and dust, but the gas and dust behave as if they are reading from something anchored. Edges in flow sit where edges in the body would sit. Vertices, where water brightens and where polarization tilts, are the same places where background stars dip deeper and where the velocity field changes its sign. The coma appears to be the messenger rather than the author. If the core holds ridges or seams that trace this plan, the messenger makes them legible. If the core is smoother and the plan is a stable flow pattern of its own, the stability must be enforced by something other than wind. There is one more practical test already on the schedule circled in calm ink. A view from a different world will angle lines of sight enough to push the tomography beyond small parallax, turning inference into depth. Until that day arrives, the working map carries a quiet label, the outline anchors light, the coma displays it sometimes with flourish and sometimes with restraint, but the phase lock, the depth, the timing, and the thermal behavior together say that the figure rides with the body rather than with the breeze. Any story that continues from here will carry that anchor as part of its design. Chemistry becomes a map maker. Where geometry has drawn lines on light spectra begin to color those lines. The instruments that separate light into quiet components work with patient cadence. Near-infrared slits sweep across each face and border. Mid-infrared images paint temperature and composition with softer brushes. Millimeter receivers listen for molecules that turn and vibrate and reveal abundance and motion. Each method brings its own habits, yet the figure persuades them to agree. Water speaks first because it is both common and sensitive. In bands where sunlight shakes the molecule into emission brightness, concentrates near the 6 corners. When the object turns, that pattern rides the corners as if the vertices host seams that breathe more freely. The total output looks ordinary for a traveler at this distance. The uncommon part is refusal to smear across the faces. A quiet excess repeats at each vertex within narrow uncertainty phase, locked to rotation without measurable lag. Carbon dioxide answers with a different habit. Narrowband images and high-resolution spectra prefer the long runs rather than the points. Along each border, the emission deepens like a stitched seam. It is subtle in any single frame and strong in careful stacks, a paradox now familiar. A plain reading suggests that straight walls favor straight flows. Heat collects along a line, fractures align with that line, and gas that finds a channel prefers to stay in that lane. Faces remain even. Dust enters as the oldest partner and answers with color and polarization. Grain sizes inferred from reflected light and from the shallow tail of thermal emission look ordinary in bulk yet unusual in placement. Faces carry a slightly finer mix, as if small grains linger where flow is gentle. The electric field angle of scattered light tends to lie parallel to the edges, a quiet sign that facets share an orientation set by the boundary. Metal appears where few expected it. In optical and near ultraviolet bands, faint lines traced to neutral nickel rise above noise. Iron would normally accompany them in similar strength, yet iron hides while nickel repeats near the same corners that water favors. The ratio is not a verdict, it is a clue that returns across instruments. A careful reading is that grain chemistry near the vertices differs from that on the faces in a way that favors nickel release or survival. Isotopes give their own counsel. The ratio of carbon-13 to carbon-12 in carbon dioxide is not the value catalogued for many comets. The difference is modest and steady, drifting across the hexagon with the heavier isotopes slightly enhanced near the corners. Nitrogen shows a related but smaller effect. Temperature, condensation order, and slow diffusion can shape isotope fields, yet those processes rarely draw rulers. Here, the gradients line up with rulers already present in the light. Mid-infrared spectra add another shard. Broad features that belong to silicate minerals are muted across the faces and recover beyond the borders, as if the planes carry a skin that softens the usual signature. In the same data, narrow absorptions tied to aromatic bonds strengthen along the lines. The mix is awkward for a uniform crust and makes sense if faces are mantled by an even layer while borders expose material richer in complex carbon. Temperature plays both messenger and referee. Maps that fold many minutes into a single rotational phase show faces of nearly even warmth. Along the borders, a slightly higher color temperature repeats, and the step does not heal as quickly as evening would suggest. It lingers through phase like a shallow reservoir of heat, or like materials of higher conductivity tracing the edges. Faces cool and warm like sheets. Borders behave like rails. Velocity ties chemistry to motion. In millimeter lines that carry Doppler shifts, water speeds rise where corners brighten, and carbon dioxide streams a little faster along each edge than across each face. The changes are modest and faithful. Integrated momentum remains small, and the path through space shows no strong, non-gravitational push despite persistent activity. That calm accelerometer has been part of the puzzle from the beginning, and chemistry leans the same way. The search for a single natural key is kept honest and comes up empty. Fractionation does not draw straight lines, and grain sorting does not lock vertices to a clock. Outgassing along fractures can build seams, yet the faces would then inherit rubble, and they have not. Electrostatic levitation can lay mantles that mute mineral features, yet mantles usually show streaks and seasonal pulses. Each process helps a little. None by itself explains a figure that stays this tidy while the body exhales. A different style of modeling keeps the thinking grounded. Surface and flow are coupled in forward simulations with sources placed only along the measured borders and at the 6 vertices and strengths that vary with illumination. The synthetic Comet reproduce brightness polarization and gentle velocity contrasts only when sources are tied to the border and rotate without lag. When sources are randomized over the faces, the fit falls apart first in polarization and then in velocity. From that restraint, a simple stance follows. Do not name an author. Define the stitch any author must satisfy. If the body is natural, surface processes must sort elements along rulers anchored in material or unusually stable flow. If the body is more than natural, the same measurements read like schematics. In either case, the map is not a metaphor. Water rides the corners, carbon dioxide runs the edges, dust aligns with the borders, and heat draws a step that repeats. The figure is stitched by chemistry and drawn by light. Coordination becomes its own instrument. The first days after the outline appears are spent not in pronouncements but in careful plumbing so that many hands can share the same water without muddying it. The European Southern Observatory posts raw photon counts, calibration frames, and header logs to a repository that records every change in plain language. The Minor Planet Center circulates refined ephemerides with uncertainties that are spelled out rather than implied, so pointing plans can be built without improvisation. The International Asteroid Warning Network opens a standing channel, the kind that usually waits for impact exercises, and fills it instead with cadence tables, filter choices, and sky brightness forecasts. What might have been a scatter of eager attempts begins to read like a single quiet score. Standards are gathered from the shelf and refreshed. A small list of polarization reference stars is agreed upon so that instruments that speak different dialects can calibrate to the same compass. A shared set of photometric 0 points is drawn from stable fields that nearly every facility can reach in a single night. Even the language of file names is harmonized so that a stack of images from 3 continents will sort itself without argument when it arrives on a common disk. None of this is glamorous. All of it is the reason large collaborations do not slip on their own shoelaces. The Planetary Defense Coordination Office at the National Aeronautics and Space Administration assigns a liaison who does not tell anyone what to see, only helps them not to miss one another. Time zones are mapped against the measured rotation so that a full spin can be covered without gaps. When dawn closes a dome in Chile, night is ready on Mauna Kea and on Haleakala. When the Pacific darkens, Canary skies are coming on. When the Atlantic brightens, a mountain above the Atacama looks east once more. This relay is not a scramble. It is a breath that is measured in and out for as many days as weather allows. Peer review remains the long road, and so the early weeks are given to preprints that explain methods before they advance claims. Authors write with a diction that spends its adjectives on procedures, not on outcomes. The figures that lead those drafts are not the prettiest images, but the most informative ones, showing how an edge survives choices in background subtraction, or how a vertex holds its position when the point spread function is modeled two different ways. Code is made available in plain repositories, and when a routine is tied to a particular machine or library, a second routine is built by another team on another continent that agrees within stated tolerances. The point is not to speak with one voice, but to sing in tune. Public language is paced on purpose. Press offices for the European Southern Observatory, the National Aeronautics and Space Administration, and the European Space Agency confer and agree to a cadence that puts caution first. Short notices acknowledge the geometry without raising a flag for any one interpretation. Phrases like under investigation and multiple hypotheses under active test appear often and without apology. The choice is not timidity, it is respect for the way trust is earned when the sky chooses to be interesting. When interviews are requested, senior scientists welcome them and keep to what has been measured, not to what might be. They describe the outline, the angles, the steadiness through rotation, and the odd persistence across colors. They do not volunteer more than that. Inside the collaboration, the tone is brisk and kind. Small disputes about a fraction of a degree here or a few tens of meters there are welcomed as proof that skepticism is alive in the bloodstream. A standing note reminds everyone not to peek at one another's interim numbers until methods have been locked. Another note reminds everyone to write down in plain words what would change their minds if a preferred pathway were to fail. These little customs are not theater. They are the scaffolding that holds the work steady while curiosity and doubt trade places at the front of the line. Scheduling so often a background chore becomes a source of clean data. The James Webb Space Telescope is given a narrow window when the object sits in a safe pointing zone, and thermal instruments are tuned to emphasize uniformity over drama. The Hubble Space Telescope is threaded into a tight sequence that favors ultraviolet bands on nights when ground air is least cooperative. Ground arrays in Chile and in New Mexico and in Spain are assigned molecules that suit their strengths and overlap. Nights are built in on purpose so that cross-checks have real teeth. Even small facilities are woven into the plan because a long level light curve from a modest instrument can be a stronger referee than a single sharp image from a giant. Archiving is treated as part of the science, not an afterthought. Every version of a reduction is preserved with a short note that says why it was made and what changed. Negative results are saved beside positive ones because a filter that fails to find the border on a noisy night will teach a later student why noise matters when a new instrument tries again. A handful of graduate students are asked to try to break the whole arrangement by reproducing key results from scratch with only the written descriptions to guide them. Their success is a quiet, important figure in the margin. International habits sometimes at odds are let stand where they do not harm and merged where they do. Some groups prefer to push images through a clean pipeline and never touch a pixel by hand. Others allow gentle hand placements for seed points and then lock the analysis after that. A compromise emerges that is as simple as it is effective. For the same night, both strategies are applied and results are reported blind at first and then reconciled. When they stand together, confidence grows. When they disagree, the disagreement is treated not as failure, but as a map of where the next effort should go. Through it all, the central fact remains quiet and immovable. Straight edges keep their places, angles stay near the classroom value, faces remain even inside the limits of sight, chemistry follows the plan, time refuses to spoil it, coordination does not create those properties, it keeps them from being mistaken for something else, it turns a handful of persuasive nights into a record that an outsider can examine without trusting anyone's excitement. There is a moment late in one of those long teleconferences that cross oceans when a senior observer who has spent a life in careful light sighs and says that the work now is to keep the world from running ahead of the numbers. The group agrees and goes back to plotting exposure sequences and listing calibration stars. The hexagon does not ask for a verdict, it asks for discipline. The community answers with the slow grace that centuries of practice have taught, and the result is a structure around the structure protocols that let the anomaly breathe without turning it into an argument too soon. By the end of this phase of quiet logistics, the collaboration has built something as valuable as a sharp image. It has built the conditions under which those images can be believed. Raw counts flow where they need to go. Standards keep instruments honest. Schedules cover the spin. Preprints describe what is done and how to repeat it. Public language keeps faith with the truth. Curiosity and skepticism share the same table and eat from the same plate. The science has learned to breathe deeply and evenly, so that whatever the hexagon finally means, it will mean it on the far side of care. A new angle becomes a new instrument. The plan that light has been drawing from Earth now asks for parallax large enough to turn outline into relief. Mars offers that angle. Spacecraft in orbit around the red planet can watch from tens of millions of kilometers to the side far enough that the lines of sight through the coma differ from those traced by ground observatories and by telescopes above the air. The Mars Reconnaissance Orbiter adds a narrow imaging sequence to its schedule, and the European Trace Gas Orbiter reserves passes for limb scans and radio occultations. Neither spacecraft was built for this visitor, yet both can read the geometry from a vantage that Earth cannot provide. The first images from Mars orbit arrive with the soft blur that belongs to cameras tuned for landscapes and skies. Even so, the border emerges. The hexagon is present rotated by perspective and slightly foreshortened along one pair of faces, the way a tidy box looks thinner when seen from a corner rather than from straight on. When frames from Earth and from Mars are placed on a common ephemeris and aligned by rotational phase, the corners meet with the calm inevitability of solved geometry. The outline is the same shape seen from two different lines of sight, and the agreement falls within the stated uncertainties without help from interpretation. Depth is written into shadow and into gradient. From Earth, most views have placed the hexagon nearly face-on. From Mars, the same structure tilts. Along several stretches of the border, a dark fillet clings to the interior side, growing and shrinking with phase in a way that reads like a low wall catching its own shade. Brightness profiles measured across those places are a little steeper than across the faces, and the change with perspective is consistent with a ridge that rises a few hundred meters above the surrounding plane. The effect repeats on multiple borders and refuses to vanish when images are rotated, rescaled, or processed with different kernels. It behaves like topography rather than glare. Background stars add their needles to the fabric. As the spacecraft track faint points pass not only through the coma, but also behind the border where foreshortening is greatest. Starlight dips by tiny measurable amounts that recur when the orbital sequence returns to the same phase. The timing of those dips against two separate clocks, Earth's and Mars's, helps place the border in 3 dimensions instead of 2. The wall is no longer only a line on the sky. It has become an edge with depth that can be triangulated. Spectroscopy from the Trace Gas Orbiter fills the map with chemistry seen from a fresh angle. Lines tied to water vapor peak near locations that Earth watchers have already treated as vertices, and they peak at the same rotational phase once the two clocks are reconciled. Emission associated with carbon dioxide is brightest along the long runs between corners, a habit that the Mars Vantage affirms rather than revises. Even a faint repetition of the unusual nickel signature appears in the right places when the signal is stacked with patience. The chemistry that drew the outline from Earth now draws it again from the side. Motion keeps faith across the gap. Millimeter receivers on Earth have drawn small differences in gas speed along borders and across faces. Radio experiments taken as the Trace Gas Orbiter slips behind the object's halo measure equivalent drifts in a way that cares little for reflected light and much for density and velocity. The numbers agree where they overlap. Where Earth sees slightly faster flow along the edges, Mars confirms the same preference from the side. Where corners carry a little more water, Mars sees that concentration in limb scans that favor the same points. A brief interval of simultaneous viewing brings a dynamic test that single vantages cannot offer. During one full rotation, instruments on Earth and around Mars record small coherent brightenings that ripple along one border and then the next, as if a modest pulse of activity runs the circuit. The delay between the two recordings matches the light travel time and the difference in viewing geometry. When the two movies are laid together on a shared timeline, the ripple traces the same path in 3 dimensions, and the phase of the ripple remains tied to the rotation of the body rather than to any fixed direction in space. Relief estimates taken with all these threads in hand settle toward a simple picture. The borders behave like ridges a few hundred meters tall and roughly 50 meters thick, rising above faces that are smoother than small bodies usually allow. The values carry generous bars of uncertainty as they must, yet the order of magnitude is stubborn against changes in method. Whether the crest is closer to 200 meters or to 300 meters, the conclusion is the same. The edge is not only a contrast in light or chemistry, it is a physical change in height that casts and receives its own shade. Tests of projection illusions are repeated with this new confidence. Models that once could be tuned to draw a passable hexagon in 2 dimensions now must also produce the right parallax between Earth and Mars, the right timing of star dips, the right behavior of the thermal step under foreshortening, and the right chemistry as seen from the side. Those models grow brittle. They require conspiracies of grain size flow and viewing phase that would all have to align for many weeks while the solar wind and the rotation both change. The simpler reading that borders really are borders in space survives the comparisons that break the more delicate explanations. A few oddities add texture rather than contradiction. In the Mars perspective, the polarization signal weakens slightly along one face that Earth expects to be strong. In Earth's view, the same face shows a barely higher color temperature than its twin across the hexagon, as if the surface there conducts heat a little differently. These differences are modest and repeatable. They hint that the plan is not painted on identical panels, but on panels that share a rule while carrying small lawful variations in composition or packing. The practical language that guides the collaboration remains careful. The parallax data are consistent with low relief along the borders, and the simultaneous observations are consistent with a body-fixed geometry that the coma obeys. Within that framing, the picture that began as an outline acquires character. The edges shade themselves. The face is warm and cool as even plates rather than as broken fields. Gas steps up its speed along lines and gathers in points. A map that once seemed to live only in brightness now carries height, heat, and motion in the same places. By the time the Mars campaign winds down, the hexagon has gained depth in a literal sense, and in a figurative one, it is no longer only a pattern that endures through color and through time. It is a relief that shades itself a seam that holds a little extra heat, a border that carries a slightly faster wind, and a geometry that 2 worlds can read in the same language. The questions that remain are not whether the plan is real, but how such a plan could have been made, and how it keeps its crispness, while the body rotates, exhales, and crosses a changing field of light. The furnace test arrives when Earth can barely watch. Near conjunction, the visitor slips toward the sun, and the sky around it climbs into glare. Telescopes on the ground and above the air yield to daylight and to geometry. A different vantage steps forward. The Parker Solar Probe, moving on its inward loops, carries a wide-field imager meant to read the glow and structure of the solar wind. For several days in late November and early December of 2025, that imager gives the only clear, persistent view. From the solar side, the coma is a veil against a bright backdrop, and the figure must declare itself through a crowded field of coronal streamers and moving light. It does. The first sequences are humble and careful. Calibrations are pulled from quiet solar days that bracket the observing window. Stray light is modeled, and coronal features that mimic edges are mapped and removed with methods developed to study ejections from the sun. Against that shifting fabric, the traveler appears as a compact, high-contrast patch. Frame by frame, and then in stacks that hold minutes together, straight lines begin to assemble. They meet where they should. Perspective foreshortens one pair of faces, but the ratios remain within the small tolerances that weeks of Earth-based astrometry have set. The hexagon looks back from the bright side of space. Activity rises with heat as the approach tightens. The coma swells and the surface breathes faster, yet the extra breath respects the plan. In the image plane, small brightenings walk along edges like gusts funneled by a levee, and then they fade without blurring the levee itself. Short, coherent pulses appear near vertices and run for a time around the border, an echo of the ripples that 2 vantage points have already shared, now seen under sterner light. The figure does not sharpen with heat, but it does not wobble either. It keeps its poise while everything within it crowds its lanes. Polarizing filters in the imager add a quiet constraint that belongs to geometry rather than to brightness alone. The degree of polarization rises modestly along the borders and shifts its angle to lie more nearly parallel with the edges, even as particle sizes in the coma change with sublimation. That alignment measured against a luminous background and under illumination that would expose any quirks of scattering repeats the habit seen from Earth and from Mars. The vectors look like stitches drawn along a seam and not like a spray of threads. Field's instruments on the spacecraft offer an independent, cautious hint of structure. As the probe crosses sectors of solar wind that pass near the object, the magnetic field shows subtle deflections that are repeatable and largest when the line of sight brushes the vertices. The magnitudes are small and fall well within the tame end of fluctuation expected in that environment, yet their coherence in time and their preference for the six corners suggest that the wind feels the coma in a way that remembers the plan. It is not a shield, and it is not a bowshock. It is a whisper of ordering impressed on a flow that rarely admits such persuasion. Thermal stress becomes the day's central question. Models that let ordinary mantles hold a tidy face expect to lose their grip when surface temperatures climb into the realm where ice flees quickly and dust is unseated. The imager itself does not measure temperature, but it reads the consequences of heat. In the hottest hours of closest approach, the coma grows jets strengthen and small filaments thread the interior. If there were an underlying roughness waiting to be revealed, those filaments should begin to tug the border into scallops and bays. They do not. Edges continue as edges. Faces keep their evenness at the instrument's resolution. Whatever keeps the plan legible in cooler light keeps it legible here. Timing is used as a lever against wishful reading. The object's spin remains near 18 hours. If a lag between surface and coma were to grow under intense heating, the border traced by dust and gas would fall behind the border traced in reflected light at cooler times. Cross-correlation of the solar side sequences with the earlier colder stacks searches for that slip and finds none within the narrow bracket allowed by the cadence. The phase of the hexagon with respect to rotation holds as before. The messenger keeps pace with the anchor. Another check folds the border into the broader environment rather than carving it out of the field. Coronal streamers that drift across the imager occasionally wrap around the coma like gauze pulled past a lantern. If straightness were an illusion born of a particular lane through the corona, the pattern of edges would change with each streamer's approach. Instead, the streamers cross and do little more than add and subtract a small predictable glow. The lines belongs to the traveler and not to the background through which it moves. A few delicate mismatches teach caution rather than doubt. Along one face that earlier vantage points found slightly warmer than its opposite, the solar side images reveal a longer persistence of fine filaments after small brightenings. The difference is consistent with a surface that conducts heat a little more efficiently there, keeping dust mobile for a few minutes more. At one vertex, the expected pulse is briefly weaker, then returns 3 rotations later with its prior strength. None of these departures change the plan. They give it texture that is lawful and repeatable. Instrument limits are kept in view. The imager's optics are tuned for wide, faint structures, not for small bodies, and the signal must be carried through a field full of solar detail. For that reason, each claim carries its own restraint. Straightness is claimed only where independent reductions that subtract the corona differently agree. Polarization is plotted only where the background is flat in time. Field deflections are treated as suggestive because the probe and the object do not share a frame and the solar wind is changeable. Even within those guardrails, the picture that emerges is the same one that Earth and Mars have been drawing. Order survives heat and glare. The furnace test does more than add another checkmark. It narrows the stories that can stand. A border written only by flow should distort when driving grows strong. This one does not. A face held together by fragile mantles should break its evenness when sublimation quickens. This one stays level within the floor of sight. A plan that depends on a fine balance of scattering should fail when particle sizes shift under heat. This one keeps its polarization map. What remains must include a structure with memory or a system with control, natural or otherwise, that continues to enforce straightness and uniformity when the environment turns harsh. By the time Earth's view opens again, the geometry has passed through its brightest trial. The hexagon has held under the closest approach to the sun that this orbit allows in light that exposes and in heat that rearranges. It has done so without asking for a special epoch or a friendly sky. The result is not an answer. It is a stricter set of conditions that any answer must satisfy: order under fire, steadiness under pressure, and a messenger that keeps to its template even when the breeze grows strong. The object moves on cooling as it goes. The outline remains ready for the next instrument that will ask a different question and expect to hear the same calm reply. Heat becomes a language that the outline must speak without help from reflected light. The James Webb Space Telescope turns its mirrors toward the traveler when geometry allows, and the instruments that listen in the near and mid-infrared begin to draw their own quieter map. The plan is simple in spirit and careful in practice. Measure temperature as a field rather than a number. Separate the light into its patient bands. Ask where certain bonds drink the starlight and where they let it pass, and then see whether those answers respect the same ruler that visible images have already laid down. Temperature is the first surprise, and its tone is modest rather than dramatic. Across each broad face, the color temperature varies by less than 10 degrees when frames are stacked by rotational phase. Illumination changes, shadowing changes, the coma breathes, and still the plates behave like even sheets. Along the borders, a shallow step repeats a narrow lane that sits a little warmer than the faces and holds that extra warmth longer as the angle of sunlight drifts. It is not a flame. It is the kind of small persistence that materials with higher conductivity would show, or that a buried framework would enforce by moving heat side to side faster than a patchwork crust can manage. The step returns on every edge within the limits of sight like a refrain kept at low volume. Spectra add color to that restraint. In the near infrared, where simple molecules and delicate chains take their turns, narrow absorptions tied to carbon-nitrogen bonds and to aromatic rings appear a little stronger along the borders than across the faces. The pattern is not loud in any single exposure. It grows as stacks grow and as rotations are co-registered. In the mid-infrared, where minerals often make themselves known, broad features that belong to silicates are muted across the hexagonal planes and recover outside the figure, as if an even layer is masking the usual mineral voice within the geometry. The two habits fit one another gently. If faces carry a mantle that softens mineral signatures and edges expose or concentrate materials richer in complex carbon, then the contrast takes on a logic that light alone could not supply. Carbon dioxide, so persistent in earlier maps, now shows a finer structure. Along each long run between corners, brightness is not one continuous seam, but a cadence of small peaks, each separated from the next by a distance on the order of 700 meters. The spacing is not perfectly regular, and it need not be, but it is stubborn enough to resist noise and method. Water continues to favor the vertices, building small rounder peaks that ride the corners through rotation. The chemical pattern thus learns a meter that geometry had only implied, a sequence along the borders and a pulse at the points. Isotopes give their steady counsel. Ratios of the heavier carbon to the lighter carbon and carbon dioxide are shifted from values catalogued in many comets, a familiar sign that the object comes from a different history of formation. More quietly, those ratios themselves vary across the figure. The heavier species is a little more common near the vertices than along the faces. Nitrogen offers a similar but smaller echo. Fractionation can arise from temperature-poor structure or slow diffusion through layered materials. Those pathways are physical and natural, and yet they rarely arrange themselves into neat rulers. Here the gradients align with the same straight lines that light and heat have traced. Polarization survives in heat as a faint but persistent guide. Even at wavelengths where polarization is shy, a small preference remains for vectors to lie parallel to the borders when emission is taken from the faces and the edges separately. The signal is at the limit of what the instrument can carry, and it is treated with care. Stacks that relax the registration erase it. Stacks that follow rotational phase recover it. The consistency with shorter wavelengths ties texture, chemistry, and temperature into the same map. Velocity returns to the conversation by way of the molecules that hum in the millimeter. Higher sensitivity at longer baselines allows small differences that earlier campaigns only hinted at to settle into numbers. Along the borders, carbon dioxide streams a little faster than across the faces. Near the vertices, water gains a small speed that is coherent from corner to corner. None of this adds up to a strong non-gravitational push. The path through space remains the quiet curve that gravity sets. The modest drifts tell a simpler story. Sources are organized, and the coma reads from that organization rather than inventing it. Every claim passes through the same sieve of doubt. The uniform temperature across faces could be an artifact of deconvolution, so reductions that avoid deconvolution entirely are compared with reductions that apply it gently and with those that blur the image on purpose before analysis. The result does not change. The aromatic and carbon-nitrogen signatures along the borders could be a trick of mixing so synthetic spectra that blend many species are built and forced through the same retrievals. Those mixtures can fit parts of the map, but they fail when asked to fit temperature, chemistry, and polarization at once. The cadence in carbon dioxide along the borders could be speckle masquerading as structure, so the cadence is sought at fixed phase across nights. It returns with the same interval within generous uncertainties. The language used to describe these findings stays even. The faces are not called panels, they are called planes with unusually even thermal behavior. The borders are not called seams of machinery, they are called ridges that hold and shed heat in a way that is hard to reconcile with rough, unconstrained crust. The cadence along the edges is not called a grid, it is called a sequence of sources that repeats more regularly than fans carved by chance. The restraint is not a performance, it is a way to keep curiosity inside the lines drawn by the numbers. Taken together, the infrared view does not replace the map already built in visible light and radio. It deepens it. A figure that once lived as straightness and angle now carries habits of heat choices of composition and gentle rhythms of emission that respect the same plan. If nature has drawn this, then nature has drawn an object that distributes conductivity along borders while mantling faces with a more uniform skin, that places vents or fractures in a spacing that reads like a pattern rather than like rubble, and that somehow moves gas in lanes and pulses without building a measurable shove against its own path. If something more than nature has drawn it, then these are the kinds of design choices that would make sense: heat sharing along frames, uniform radiating surfaces across fields, sources laid out with measured separation and chemistry, organized by function rather than by accident. The numbers are not a verdict, they are constraints that grow stricter as new instruments add their quiet weight. Any story that keeps faith with them must now carry a figure whose faces refuse to develop large thermal gradients, whose edges prefer to be slightly warmer and a little faster, whose chemistry lays down a repeating spacing along the long sides and a concentration at the corners, and whose isotopes drift in a way that respects the geometry. The sky has not told why such order exists. It has told with unusual patience that the order is real, and that it keeps its voice across many ways of listening. By the time these infrared chapters are written into the shared archive, the outline has learned to speak in heat as fluently as it speaks in light. The calm that began as straightness has become a wider discipline, a map that does not waver when asked different questions, a plan that seems to include how to hold warmth, how to place sources, and how to keep textures quiet while activity rises and falls. The next instruments will not be kinder, they will simply ask in other tongues. The figure waits, and when asked, it tends to answer with the same measured ease. Prediction becomes the discipline that keeps speculation honest. The outline is measured, the chemistry is mapped, the relief is inferred, and the calm through heat and rotation is established. What remains is to state in plain terms what must be seen next, if each broad class of explanation is to survive. Natural stories require signatures that belong to fracture mantle sublimation and slow sorting. Artificial stories require seams periodic placement control of heat and organization that persists when conditions change. Between those poles sits the wider possibility of processes not yet named that nevertheless obey physics already known. The collaboration writes these expectations down where everyone can see them, so that future measurements arrive into a room that has already agreed on what would count. Trajectory is the first arbiter. If the geometry channels activity, the coma should have impulses that cancel better than they push, and the path should remain close to what gravity alone predicts. If the geometry hides a system that actively balances force, small deviations might appear after closest approach to the sun, when pressure from light and gas both change in a way that real control could answer. Astrometry with tight error bars is therefore given long hours across the months that follow. The rule written in advance is simple: if any net drift appears, its direction must follow the rotating frame rather than any fixed vector on the sky, otherwise control can be dismissed and symmetry can be blamed for the calm. Radar is the second arbiter because it reaches beneath the coma to listen for surface and interior. The Goldstone transmitter in the Mojave Desert, paired to large receiving dishes on other continents, is scheduled for windows when geometry is kind. If the faces are even mantles and the borders are ridges with organized material, radar echoes should change in a layered way as the figure turns with stronger, more specular returns near edges and a steadier low-contrast sheen across faces. Polarization in the echo, if it repeats at the same phase and angle through many passes, would favor an organized surface over an accidental crust. Thermal response at changing solar distance is the third arbiter. As the object recedes and heating eases from the furnace of late November toward the quieter light of early spring, faces that are uniform by mantle should cool and warm in a way that is linear and slow. Borders that carry higher conductivity or hidden frames should keep their shallow warmth longer than that linear expectation. The rule written down is modest if the small thermal step along edges persists with nearly the same amplitude, while overall temperatures slide. It must be kept in any model that claims to be only frost and dust. Timing of sources is the fourth. The cadence along borders that appears in carbon dioxide, the pulse at corners that appears in water, and the gentle ripples that have been seen to run around the rim must prove themselves more than favorable weather. If those rhythms are real, they should remain in phase with rotation over many cycles and reappear after periods of glare and quiet. The test is recorded as an expectation recover a similar spacing and a similar pulse after weeks lost to geometry, and the argument for chance weakens. With those promises and traps in hand, the conversation that spans agencies and continents takes a step that belongs to spacecraft rather than to telescopes. The National Aeronautics and Space Administration weighs the possibility of turning an existing mission toward the visitor. The Jupiter orbiter, named Juno, is the candidate because its instruments can measure heat and magnetic fields with a delicacy that no remote stack can match, and because its path near Jupiter offers maneuvers that, while costly, could rethread its future into a brief rendezvous. The choice is not a contest between drama and duty. It is a trade between a program that has been rewriting the story of a giant planet and a chance to look closely at an object that stands alone in the record. Engineering places numbers beside the hope. A deep pass by Jupiter in early December can bend the trajectory and with a long burn at the right moment send the spacecraft onto a path that will cross the travelers in mid-March of the following year. The price is high. Fuel reserves will be cut to a thin margin, and plans to continue mapping Jupiter's gravity and auroras for many more orbits will be curtailed. Navigation speaks plainly about uncertainties and windows that close. Instruments are polled for their health and their appetite for an environment they were not designed to meet. The answers are sober, the risk is not trivial, the opportunity is singular. Science writes its own ledger. Close flight past the outline would test in minutes predictions that months of remote watching can only approach. If the borders are ridges, imaging should show their thickness and texture. If faces are mantled, high-resolution thermal mapping should reveal whether roughness is truly quiet at scales smaller than a city bus. If vertices host sources, ultraviolet spectrographs should see compositional changes more sharply than stacked spectra can. If organized materials live in the frame, magnetometers should read small, coherent changes in field as the spacecraft skims along the edges. The promise is not certainty. It is leverage that multiplies every other investment already made. The debate that follows is neither loud nor theatrical. Planetary scientists who live with Jupiter's weather and interior remind the group what continued orbits would still buy. Others point to the record that has been built from Earth and Mars and from the solar side and say that an hour of proximity could transform that record into an archive that will carry a field for decades. Administrators ask whether the public language can carry uncertainty without breeding confusion, and insist that claims remain tied to measured thresholds. The answer from the collaboration is the same as it has been since the outline first appeared: state the numbers, keep the tone level, and let the sky write what it writes. A date is chosen and announced with the same restraint that has marked all of the notices so far: a planned maneuver in early December to set a course for a narrow pass in mid-March contingent on health checks and navigation that stays within margins. Schedules pivot in response. Ground radars keep their windows. Infrared facilities plan for cooling phases. Polarimetry and astrometry build calendars that bracket the encounter. The written predictions are left in place where all can see them. The encounter may confirm them, contradict them, or complicate them. In each case, the result will be an answer that moves the question out of argument and into evidence. While the spacecraft teams prepare, the wider community continues the steady work of care. Manuscripts under review are revised to include the new parallax and the furnace trial. Talks already scheduled for winter meetings update slides to show the infrared cadence and the radar expectations. Journal editors ask for language that separates measurement from inference and for figures that admit noise where it still rules. No one writes conclusions that the encounter has not yet earned. The discipline feels almost old-fashioned in a world that moves quickly. It is chosen because it is the only way to keep trust, when a result has the power to pull attention beyond the small rooms where numbers are kept clean. By the close of this chapter, prediction and plan are woven tightly. Conditions are written down in advance, instruments are placed to test them. A spacecraft that has lived for years among a giant planet is asked once to step across interplanetary space and give an answer that nothing else can. The hexagon remains what it has been since the first careful night's A Quiet Examiner. Soon it will be seen at a range where pixels are small enough to meet stones, where heat maps touch texture, and where fields read frames if frames exist. Whatever is learned, it will land inside promises made beforehand, and the story will change not because it wished to, but because evidence told it to. Close looks replace inference. The Jupiter orbiter named Juno is granted its hard assignment, and the path is changed during an early December pass, so that in mid-March the spacecraft will sweep past the traveler at a range where pixels can meet texture and fields can taste structure. Weeks of quiet cruise lead to hours of careful pointing and minutes of closest approach. Instruments that have spent years reading a giant planet now turn toward a small, disciplined geometry in open space. The encounter is brief, its temper is calm, its results are the kind that settle arguments without raising voices. Images arrive first, and they behave like doors opening from a corridor of suggestion into rooms of detail. What had been a line in light becomes a ridge in relief. Each border rises above the adjoining plane by roughly 300 meters and carries a crown near 50 meters wide. The crest is not razor sharp, it has a gentle camber that reads like built strength rather than a crumble. Faces inside the figure are startlingly even at the working scale. Within the limits of 5 meters per pixel, there are no obvious boulder fields, no craters, and no gullies. Subtle ripples exist, but they are subdued, as if a process has damped small roughness across distances that normally multiply it. Edges meet at corners that even under this sharp gaze remain straight within the floor of sight. The ruler keeps its promise. Vertices, which remote spectra had already taught everyone to respect, now reveal their own quiet machinery of form. Each junction hosts a darker circular feature near 100 meters across, ringed by faint concentric bands that appear to descend. In several narrow trenches run a short distance outward along the adjoining borders like seams that accept or release something at regular intervals. The spacing of those trenches loosely echoes the cadence that carbon dioxide displayed along the long sides in infrared maps, a rhythm that now ceases to be an inference and becomes a pattern traced by shape. Thermal instruments lean over the scene and speak in their slower, even register. Faces sit within a band of temperature that varies only by a handful of degrees across distances where sunlight and shadow would normally play a larger game. Along the ridges there is a shallow repeating step in warmth that persists longer into local night. That persistence is modest and consistent. It reads like higher conductivity along a frame, or like material with a slightly different emissivity tracing the border. At the darker vertex circles, heat leaks are small but real. A few tens of degrees above their surroundings, they brighten and fade with the 18-hour rhythm without drifting in phase. There is energy there working gently in time. Fields add their signatures with the same restraint. The magnetometer registers organized changes as Juno skims past a border and then a vertex. They are not large, nothing here is large. Yet they repeat from edge to edge and peak near the junctions as if localized weakly magnetized material or soft currents are present where lines meet. The pattern is not consistent with a global dynamo. It is more like a lattice that holds a trace of alignment or an arrangement that guides charged grains and ions in repeatable ways. Variations in plasma density measured by the spacecraft agree with that picture. There is structure, not shock, choreography, not force. Particles and light close the loop on what distant spectrometers had only hinted. When Juno looks across a face and along a ridge, instruments that listen for molecules confirm that water emerges preferentially at vertices and that carbon dioxide prefers lanes laid along borders with gentle speed, increases that match the small steady Doppler shifts heard from Earth. Dust grains lifted within the hexagon are on average a little finer than dust beyond it. An alignment of tiny facets shows up again in polarization, measured in the near-infrared with vectors that lie quietly along the border when the instrument separates light from the coma's glow. Nothing is loud, everything is regular. Radar used in a mode finer than anyone dared to expect adds depth beneath the surface. Echoes from faces are duller and more uniform than echoes from borders, which return sharper glints as the beam walks along the crest. A handful of grazing passes gathered into a stack suggest layers beneath ridges a few meters thick at intervals that recall the spacing of the small trenches. Inside faces, the subsurface reads like an even blanket with fewer interfaces. The interpretation is careful interfaces could be strata joints or changes in packing rather than anything deliberate, yet their arrangement respects the geometry instead of ignoring it. The sum of these close looks is not a trumpet, it is a ledger. Ridges exist as physical walls of a few hundred meters in height that keep clean straightness and meet at corners near 120 degrees. Faces are unusually even down to a scale of a few meters and hold uniform temperatures with a steadiness that is uncommon. Vertices host circular structures that are darker, slightly warmer, and organized, and they send signals outward along the borders in spacing that repeats within generous uncertainties. Magnetic and plasma measurements show small structured changes that peak at the same places. Radar finds subsurface interfaces beneath the ridges that repeat and are absent across the broad plains. Every line in that ledger matches the map that color polarization, parallax, and time had already drawn from far away. None of those lines answers an origin by itself. Interpretation resumes, but with new boundaries. A story that is only fracture-mantle and flow must now produce ridges with consistent height and width faces that remain uncommonly smooth at scales where rubble usually speaks vertex hollows that act as gentle sources and a layered subsurface beneath borders that repeats. A story that is more than natural must now accept that there is no loud machinery, no bright waste heat, no strong field, and no obvious message, only a frame that orders heat and emission and texture, as if function were present and modest. Between those poles sit possibilities that do not yet have comfortable names, long selection, in harsh environments that prunes everything but geometry, slow, self-strengthening flows that learn to draw straightness, matter that organizes into frames under conditions not yet replicated in a laboratory. The narrator in the measurements stays even. The spacecraft has not proved design. It has not rescued the familiar. It has turned patient inferences into smaller uncertainties. It has shown ridges where lines had been hollows, where corner pulses had been layered, echoes where hints of cadence had been, and thermal persistence where a suspicion of conduction had been. When the encounter is complete and the downlink ends, the outline that once was only a shape in light is now a terrain, a shallow field of management spread across a mountain scale, and a plan that allows many hypotheses to speak, but allows none to wander far from what has been seen. The object continues outward. The small warmth along its borders fades with distance from the sun. The vertices breathe more softly. The coma thins, and the hexagon returns to being a drawing only in the best instruments. The community which has earned its caution resists the gravity of a single satisfying sentence. Papers are written with the same clean diction that began this path. Data are archived with notes that any future eye will understand. The shape now touched closely once remains both simple and deep. It is a boundary that holds a face that stays quiet, a rhythm that repeats, and an invitation to imagine mechanisms that respect what the numbers will allow.